Okay, so for chapter 6, we talked about the normal distribution curves, and we talked about using those curves to calculate a probability. All right, so I'm just going to review a couple of problems with you. So let's look at something like this, okay? It says the average time that it takes a group of adults to complete a certain achievement test is 46.2 minutes. All right, so I'm going to go ahead and just kind of jot down that my mean is 46.2. And then it goes on to say the standard deviation is 8 minutes. And we're going to assume the variable is normally distributed, which again means that we can use the normal distribution curve to work the problem. So we should draw a curve to go with each part of this. Now remember that as we look at this, if we have a problem that is talking about one person or thing, that we're going to use a certain formula, and if we have a problem that is talking about a sample, we'll use a different formula. All right, so I'm going to jot formulas down for us real quick. You want to be sure that you have these in your notes. All right, so we would have value minus mean over standard deviation. That would be the formula that we would use if we're talking about one person or one thing. And if we're talking about a sample, our formula is almost the same, except that on the bottom, remember that we're going to do that divided by the square root of n. Okay, so take a minute, make sure that you've got your formulas written down in your notes with your chapter 6 material so that you'll have that. Make a note that this first formula is for one person, one thing. The second formula, we're using it if we have a sample. All right, so when we look at the first part of this problem, it says find the probability that 8 randomly selected adults, so we're talking about 1, and we want it to be less than 43 minutes. All right, so I need to take that 43 minutes, put it into my formula for 1, and calculate a z-score. All right, so I'm going to do that first. And so my value is 43, my mean is 46.2, and my standard deviation is 8. All right, so I'm going to go to my calculator and I'm going to type that in. 43 minus 46.2, divide by 8. 2 decimal places if necessary. This one is going to be negative 0.40. All right, so then remember that we mark that off on the curve, so it's just going to be a little bit to the left of 0, right about here. All right, and we're going to draw a line. And we want to shade less than that, so we're going to be shading in the left tail of the curve. All right, and so with that in mind, then we'll go to our table, and this is table, it says on the table, table B-1. It may also say table E. It's the first table that we worked with, and we're going to look up that area. So looking up that z-score of 0.4 is going to give me 1554. So remember that, and we made a big deal of this when we learned it, that when we look up an area in this table, that we are getting the area from 0 to the number that we looked up, so 0.1554. And so if I want to find the area of the shaded region, okay, and this is something that you need to go back and look at. You remember we had 6 different cases here, depending on what the picture looks like. So you need to be sure that in your notes you have it written down. What do I do if I've shaded in the tail? And that's a scenario where you're going to subtract from 0.5. So to get my answer, I'm going to do 0.5 minus 0.1554. That would give me, as a final answer, 3446. Okay, 3446 would be my answer there. All right, so try to clean that up just a little bit so it looks like the right number. All right, 3446. Okay, so let's look at part B. Part B is going to be the same situation. The only difference is that we're going to be using the other formula. All right, so now we have a group of people and we want them to be less than 43 minutes. So I'm going to plug into my formula for a sample. So 43 is what I want to convert. My mean is still 46.2. We still have a standard deviation of 8, but now we have a sample size of 50 randomly selected people. All right, so again, I'm going to put that in my calculator, get my z-score. All right, I get negative 2.83. All right, so we're going to draw a picture of our curve. We're going to mark off negative 2.83, which will be over here on the left. We want to shade less than that, just like before, so we're shading over here. All right, we're following the exact same steps that we did in the first problem. This is negative 2.83. All right, I'm going to look that up on my table, 2.83. I'm going to get 49.77. Remember that goes here. From 0 to the number that you looked up, and in order to get your answer, you're going to subtract from 0.5 in this particular case. All right, so that will give me 0.0023. Okay, so that's an example of both types of problems moving in this particular direction where you are given information to find the z-score and you want to find the area in order to do the probability. All right, so make sure you're familiar with both of those types of problems. All right, the other thing that you need to think about for Chapter 6 would be a problem like this, where they are giving us a percentage. All right, remember that these problems can either be top some percent, bottom percent, or a middle percent. And these would be the problems where you're sort of working backwards. All right, so on these problems, you would want to draw a curve first and shade what constitutes that bottom 18%. So remember that you're either shading in the left tail, that would be a bottom, or the right tail, which would be a top, or you're shading right in the center, which would be the middle. All right, so the first thing that I need to do is I need to find that z-score. So I know that the area of the shaded region is 18%, which would be 0.18. I know that the area from 0 to z, remember if it's in the tail, you subtract from 0.5. So the area from 0 to z would be 0.3200. Now I'm going to go to my table and look that up, and remember that when you're looking at 0.3200, you're looking in the middle of the table. All right, so I'm going to find the closest thing to it, 0.3200. The closest thing to it is 3212, and 3212 corresponds to a z-score of 0.92. All right, so now I know that my z-score here is negative 0.92. All right, and then the only other thing I have to do is use my formula to convert that back to a regular number. All right, so remember that your formula is value minus mean over standard deviation. We never are looking at samples with this type of problem. So let's plug in what we know. We know the z-score is negative 0.92. We are looking for the value this time. We know the mean is 24,596. We know the standard deviation is 6256. And then your job becomes solving for the word value. So you need to multiply both sides of this expression by the denominator. That will get rid of the fraction and make it a little bit easier to work with. All right, so 6256 times negative 0.92. All right, it's going to give me negative 5755.52. And then on the other side, it's going to cancel out, so it'll just leave me the top part of the fraction. Okay, and then as a final step, you want to add the 24,596 to both sides. All right, and when you do that, you get your answer, which should be 18,840.48. All right, so that is your second type of problem. So you should expect on your final to see pretty much one of each of those. One like the first example that we just did, and then one like this example where we're looking at the area and converting back to a z-score and then back to a value.